Hello students, today we will be doing some math.
Alright, let's get started. We're going to continue our lesson on sums of arithmetic and geometric series. Last video ended kind of abruptly, so I'm glad you joined me for the second one because we do have some more practice problems to look at together. Just to recap, we had two formulas for the sum of an arithmetic series. They were this one, and this formula does come from the other through this series of steps. We use that formula when we want to know the sum of terms in an arithmetic sequence. Alright, then we looked at the sum of geometric series formula and it looked like that. Both of these are totally valid forms. We ended with a problem where we had a geometric sequence here and we were looking for the sum. So here's the sum, but we used the formula to find out the sum was negative 510. Again, I showed you how to make a fraction on your calculator. Everything else here you should have been able to punch in there. Let's take a look at the next problem. So we have this geometric sequence. So we already know we're going to deal with the geometric sequence formula, maybe the sum. And we were given the sequence with p-value here, and it has a common ratio of 0.5. Step 1, or part A, find the value of p. Well, that's pretty simple. It's 4. We can see this geometric sequence. This is 16 times 0.5. Then 8 times 0.5 will give us a value of 4. Next, part B. Find the value of the seventh term. Okay, in a geometric sequence, this is our formula for finding any term in the sequence, right? And we're going to look for U7, the seventh term. U1 goes here. Common ratio value goes here, which is 0.5, we said, and then 7 minus 1. So our seventh term is 0.25. Question C, find the sum of the first 15 terms. So now we're going to use the sum formula, right? We can use this one, and now we plug in 15 here. So sum of 15, we put U1 value here, 1 minus the ratio to the 15th power, and then 1 minus the ratio here. Again, on your calculator, let me show you one more time how to punch that in so we can be clear on that. You will create a fraction by punching alpha, y equals, and then number 1 there. Okay, so enter. All right, on top we have 16 parenthesis 1 minus 0.5. To do a power, you're going to press this button, right? 0.5 raised to the power 15. Then I'm going to use the arrow to get out of that exponent. Arrow over once there. Close that parenthesis. Go to the bottom. And 1 minus 0.5. Okay, let's press enter and see what it gives us. I see that value, 31.99. And let's check here. 31.99. Good news, everything works out. Okay, let's go to this problem here, which is on your notes page. And it is called problem 1. Please fill in this row, these values, and these values. These values represent the number of coins in each row of this pyramid here. And read the top part first. And this part of the table represents the sum of all the coins after that many rows. Okay, let's try. So first, there is 1 coin right there in row 1. 2 coins in row 2, 3 coins in row 3, and 4 coins in row 4, and if there was another row, it would be 5 coins, right? Now the sum, so after we've done one row, the sum is 1. There's only 1 so far. And after we've done 2 rows, the sum is 3, right? So we put 3 here. It's basically that plus this extra 2 makes 3. Okay, the sum after 3 rows is 6 because we had 3 and we added 3 more. The sum after 4 rows, 10 because we had 6, we added 4 more. And then 15. So that is the sum of that. This 10 here should match how many coins we have here in total because that's 4 rows and we're doing a sum. And that's right, 10 does match that. So the table is filled. Now create a general rule for the number of coins in each row. So that means a general rule for this. Can you make a rule for that? Well, hopefully you recognize that is an arithmetic sequence because it is there's a common difference of 1 between terms. And here's our rule for arithmetic sequence. Put in your U1 value 1, put in your D value, which is 1 also, and then multiply everything out, and you get this. It simplifies to that. And that makes sense because every term in this sequence is equal to the term number, right? Term number 1 is 1, term number 2 is 2, term number 3 is 3, and that's what this says. Every term is equal to the term number. So that was easy. Now let's look at C. It tells us that a rule for the sum of the coins is this. And we know again that this is an arithmetic sequence. So the sum should be the sum of an arithmetic sequence, right? But it tells us that there's also this formula for it. And this formula is actually quadratic. So let's see what happens with this. Let's use the rule, this rule that I gave you here, to find S sub 2 and S sub 4. So try that now. So using this rule, S sub 2, you plug in the 2 in there, and when you calculate it, you get 3. And it says confirm it matches your table. Well, it does. Look, sum of the first 2 is 3, and we have the sum of the first 2 is 3. And we can see that here. The sum of the first 2 rows is 3. And then S4 should give you 10. If you put 4 in there, it should give you 10. And that matches the sum after 4 rows, which is this 10. So everything's good. Now your job in this part is to show that if we use the arithmetic sequence sum formula, the one that we put on top of this page, like we wrote the two formulas, that sum formula, if you take that and you simplify it, does it give you this expression here? So let's check. So here's our sum formula, right? I'm going to use the long formula because we do not know the UN value. We're trying to make a general rule. So put that in there. Replace the U1 with 1. Replace the D with 1 as well. And then we don't know. We're trying to make a general rule, so we don't know the n value. We don't know. We're not saying if this is a sum for the first 5 or sum for the first 10. We're just saying a sum for any number. Simplify all that, and you get this. And then multiply through here. N times n is n squared divided by 2 is 0.5 n squared. And then n over 2 times 1 is also 0.5 n. So yeah, we use the general arithmetic sequence sum rule, and we simplified it until we came up with this rule it gave us here. So that's some good algebra just to see how everything's connected. Now there's a bunch of problems for you to try, starting with this one. This is a word problem, typical kind of word problem for arithmetic or geometric. So first determine, is this arithmetic, is it geometric? And then it says, how much money will this person have in total? So that's talking about a sum. How much will they have in total on the 14th day? So see if you can solve that. All right, here we go. The sequence is 0.5, 1.75, 3, and so on and so on. We can see by subtracting one term from the next one that we have a common difference of 1.25. This goes up by 1.25, that goes up by 1.25. So there's our common difference. So we've confirmed it's arithmetic. So now to find the sum, we can use the sum formula for arithmetic. And we're going to plug in everything we know. We know there's 14 days here, so there's 14 terms in this sequence, with U1 being here, our D value being here. Again, we chose to use this rule instead of the simpler one with U1 and UN because we don't know UN here. We don't know what the amount that this person got on 14th of December is. We could have calculated that and then used that formula, but by using this formula, we're basically doing that's those same two steps in one. There's your total. I hope you're able to get that same value. All right, now there's this. You're here now where there's at least 6 different sequences. It says first, decide, is it arithmetic or geometric? And then find the sum. So look at each one, arithmetic, geometric, and then find the sum. So let's get started. All right, A is this. It was arithmetic. Check your work here. There's the sum. Try B. B is also arithmetic. The common difference is 6. And the sum, again, we can use this formula. There's the sum. In C, it is geometric. And the common ratio is 2, found by dividing successive terms, right? And then you're using now the geometric sum formula. Plug in everything, solve it, and you get this value here. I would say it's really important that you're trying these steps every time because a lot of students, the calculator and the sequence of pressing buttons and all that, sometimes there's little mistakes that can be made. So keep practicing that. All right, looking at, now we're on D, so try D. This case is geometric again. Our common ratio is a half. It's being multiplied by a half every time. And we use the geometric sum formula. Lots going on there. Wow, it's showing all the steps. I guess it didn't use calculator here. It's just doing this, treating this as a non-calculator problem. And we get this answer for the sum. Try E. In E, it's back to arithmetic. Common difference of -8. using the large sum formula, solve, solve, solve. There's our sum for the first 7. And finally, F, geometric, common ratio of -2. That's a tougher one to find maybe. And then use the sum formula, we get this value here. Okay, that was lots of practice with those. I hope it made you a lot more confident with the two formulas for arithmetic and geometric series. And there's a couple more here, I guess. So let's try A. This one's arithmetic, common difference 2. And in this case, it's showing the other sequence of steps. We're using the UN formula to find out that this is the 39 is the 18th term. And now we can use the 18th term in the sum formula to figure out the sum, right? Here's U1, here's UN. We know there's 18 terms. So unless we did this here, we could not figure out that this is the 18th term. And now this one. Hope that one you recognized again that this is a geometric rule, right? This is a geometric rule. Here's our U1 value, here's our R value. So using that, we figure out the R value is 3. Let's see what's going on here. Yeah, well, let's see. We were just saying that U1 is this, but again, U1, if you put 1 in here, let's see what happens. Put a 1 in there, and that gives you 3. 3 times -2 is -6 is our U1 value there. So sorry, I just said this is U1. Not quite, and that's because this does not say n-1. So if you're confused about that, because we saw one like that earlier where this was the U1 value and this was R, but since this says n, the U1 value has to be calculated by plugging in a 1 in there and figuring it out. So U1 is -6, and then you use the rule and find this sum. Final one here, this is geometric. Here's our common ratio of 1/2. This one is like this first one here. We have ... and this one. We don't know which term in the sequence it is, so we don't know how many terms we're finding a sum for here. So you have to begin by figuring out which term this is. So you put that into your UN rule for geometric. Solve, solve, solve. You find out that n equals 7. And this step here might be tricky, but basically you're to recognize that 1/64 is really 1/2 to the 6th power. And therefore, now you have 1/2 to the 6th and 1/2 to that power. So those two powers must be equal right here, solving that. This is an important thing to be able to do. So take a close look at what happened there. And then now that you know that this is the 7th term, we can use the sum rule because we need to know how many terms there are. There's our sum rule for geometric. Solve, solve, solve. There's our answer. Okay, that was a lot of work certainly, but this is an important part of our unit here, and I hope that working through all these step by step helped you feel a little bit better about how to work with both arithmetic and geometric series and finding their sum. You can do it. Look back on anything you're stuck on, and see you in class for some practice related to this topic.